All right, students, welcome back. Part 5 of exponential rule number 1, rule of exponents number 1, where we're multiplying and dividing exponents. So we learned if you're multiplying exponents, you're just adding the exponents, and if you're dividing the exponents, you're just subtracting. So if 7 to the 9th divided by 7 to the 6th, they're the same base, I can subtract them. So 7 to the 9 minus 6 would be 7 cubed, 7 to the 3rd. Works for whole numbers, works for variables. So x to the 5th divided by x to the 4th would be x to the 5 minus 4, which would be x to the first power, or just x. And it works with fractions, and it works with negative numbers, works with any fraction. So we're just going to go 9 minus 2. Here's our base, a over b. 9 minus 2, so it would be a over b squared. We solved this one, so you can practice these on your own. All right. So here's our word problem. Exponents make it easier to multiply many times. Every time I fold a string, its length is halved. If I fold a 1,024 meter string 8 times, how long would it be? So here it is with 0 folds. It's 1,024 meters. So remember this from our first word problem. How do I go this way? What do I do? Multiplying by 1/2. So if I fold it 1 time, that's multiplying by 1/2. So that would be 512 meters. If I fold it 2 times, so it's a half of 1,024. So it'd be 1,024 times a half, which would be 256. If I fold it 3 times, it would be a half times a half times 1,024, right? If you're getting your calculator out, it's pretty simple. You're just doing 1,024 times 1/2 times, right? And if we do, you can see, let me make this a little bigger for you, right? Phones are nice because 1,024 divided by 2 divided by 2 divided by 2, and then I can divide by 2, and I can keep going, and it keeps showing up like that. Okay, but if I want to get to the 8th one, I'm running out of room for halves here, so I'm using my exponential notation. So this I'm dividing by 1/2 or multiplying by 1/2 3 times, now 4 times, 5 times, 6 times, 7 times, 8 times. So if I put it in my calculator and I put 8, 1, 2, 3, 4, 5, 6, 7, 8, right? So here it is 8 times. Oops. If you count it, can't really see it with the glare. I do it 8 times. You can see the answer is 4. There you go. And you can count the 2's. I'm dividing by 2 8 times. So that's great and all. But the real question is, how long would the string be? So the string here 8 times would be 4. But what happens if I have something and I'm dividing it in half 100 times? So what would that look like? If 8 times would be a half times to the 8th power, and 9 times would be a half to the 9th power, what would the next one be? So the 100th one would be 1,024 times a half to the 100th time. What about the nth time? What would that be? Think about it. It's going to look like this, but what is changing? That would be 1,024 times a half to the nth power. So the number of folds is the exponent, and we always have 1,024 and a half is the general equation. So the length of the string, L, is 1,024, the original length, times a half, because I fold it every time, times the number of folds. So a half times a half times a half, the number of times I folded the string. right? All right, homework is coming up. Um, Closing, so multiplication and division. We have learned the first two laws of exponents. When multiplying exponents with the same base, we add the exponents. When dividing exponents to the same base, we subtract the exponents. Okay. Homework, there's some Khan Academy and there's student workbooks if you want to look at that.